Hello everyone. Today we are going to spend a second day simplifying radicals using that quotient property we started yesterday. So this is some problems like you probably would have encountered yesterday on your homework. So if we look at question number 1 right here, neither the numerator or denominator are perfect squares. So when that's the case, we put them under the same square root sign and try to reduce, which we can. This turns out to be the square root of 9, which is simply 3. Moving on to number 2, this one, the numerator right here is a perfect square, so the square root of 100 is simply 10 divided by 4. That gives us an answer of 5/2. So now we're looking at all the different types that we did yesterday. Why don't you try number 3, pause the video, and number 4, pause the video, and then come back and watch and listen to the solutions. In number 3, since the denominator is a perfect square, we take the square root of it. That winds up having our answer to be 15 divided by 3, which is 5. In question number 4, however, you can hopefully notice that both of them are perfect squares, so we're just going to take the square root of each individually. And the square root of 196 is 14, and the square root of 225 is 15. So again, no decimal answers. You could leave it as a fraction or a whole number or a simplified radical expression. So today we're going to add variables to solving using the quotient property, or simplifying, I should say, using the quotient property. So this goes back to work we've already done this year. If we're simplifying variables, remember when we're dividing and we have the same letter, same variable, when we're dividing we subtract the exponents. So 2 minus 1, that would simply be x to the first, or just x. In question number 2, again, if I subtract these exponents, that gives me 8 minus 2, or x to the 6th. Question 3, now I have multiple letters, so I kind of take each separately. When I simplify a to the 12th over a to the 4th, that's a to the 12 minus 4, which is a to the 8th. And this gives me b to the 10th over b to the 6th. Again, this looked at separately because it has the same base. So that gives us b to the 4th. So that's just some ideas that we worked on earlier in the year. So if we look at question 4 here, what's different is we have the square root of x to the 4th. And remember, we could break that down into x squared times x squared, take the square root of each separately, and that gives us x times x. So our numerator is x squared. Our denominator is 12, and that's as simplified as we can get. So we're going to be continuing to combine all the properties together to get the answers in simplest radical form. So again, we have lots of notes here. You can pause the videos to actually copy them down. I'm going to just kind of talk through them and combine them together as we work through problems. So again, look and see if the numerator denominator are perfect squares, then just take the square root of the perfect square. And x to the 4th is a perfect square. We just solved that one, and that is x squared, because x squared times x squared is x to the 4th. So this one we already solved. Okay, y to the 6th is a perfect square. Every variable to an even exponent is a perfect square. You just cut it in half. That's y to the 3rd. So this answer is 32 divided by y to the 3rd. Here's a few more. Now we're adding numbers and letters a little bit together. So if I take the square root of 16, that's going to be 4. If I take the square root of x to the 8th, that's going to be x to the 4th. So now I have 4 x to the 4th over 3. And that's my answer. Simplest radical form. Moving on. Number 6. Again, this square root of 81 is a perfect square. The square root of x to the 3rd is not, so I'm going to have 9 times the square root of x to the 3rd over 11. But there's still a perfect square with x to the 3rd because x to the 3rd has x squared in it plus another x over 11. So again, working this kind of out the long way, this gives us 9. When I take the square root of x to the second, that's just x. And then I have times the square root of x over 11. And that would be my final answer right there. All right, you try number 7. This becomes 30 b to the 4th over 10. Don't forget though, this right here is just like a fraction. Reduce it. And that 30 divided by 10 is 3, so I end up with just 3b to the 4th when I simplify that fraction. Question number 8. You can see there's a perfect square on the bottom. Square root of 25 is 5, square root of y squared is y. So I get 40 over 5y. But again, the 40 divided by 5 gets canceled to 8. But this is where some students will make a mistake and they'll just put 8y. But it's actually 8. So this is 8 and this is 1. So we actually have 8 divided by y. So be careful on some of these. Follow your rules for fractions that you've worked on for years and years. So remember the quotient property. If you have two things divided under the same square root, you can divide the numerator and the denominator separately. So when we look at this top number, the square root of 36 is 6, and the square root of x to the 4th is x squared, and that is your final answer. So now we get into this more complicated one. When the numerator and denominator are both perfect squares, again, just take the square root of each separately and reduce your fraction if you can. So with these more complicated ones, the square root of 196 is 14. The square root of x to the 8th is x to the 4th. Over the square root of 25 is 5, and the square root of y to the 10th is y to the 5th. So I'm kind of going back and using that rule. Hopefully you're understanding that all even exponents are perfect squares. So you give number 10 a try, pause the video and see if you can get it right, and then you can restart the video and see if you did. So your answer to this next question should be 7a to the 6th over 9a to the 3rd. But now you can reduce this part of it by subtracting the exponents. So you're going to get 7a to the 3rd over 9. So always look to see if it's completely simplified and if your fraction can be reduced. I'll work out 11 and 12 in your notes. Go ahead and try them, and then go back and check the notes. But we're going to move on here. So our next piece is now, if you don't necessarily have perfect squares in your numerator and denominator, then see if you can simplify what's underneath first. Okay, so in this case, we actually do have perfect squares, so we could work it out to be x squared over x, but then we'd have to subtract those exponents and would just give us x. But we can also actually simplify what's under here. X to the 4th over x to the 2nd is x to the 2nd, which the square root of that is just x. So again, lots of times there's multiple ways to solve these. You just have to see what's going to be the easiest. So let's try a few of these, and then you'll be able to practice on your own in the homework. So we have y to the 8th over y to the 6th. If I can reduce that fraction, I'm just going to go ahead and reduce it. That's going to be y to the 4th, which is going to give us 8 minus 6 is not 4, it's only 2. Sorry about that. So this is y squared, which is simply y. Here I can reduce the r's, 9 and 7, and I can actually, in question number 15, I jumped down below, I can reduce the numbers to be the square root of 9, and I can reduce the variables to 9 minus 7, 2. So now I can take the square root of 9 and the square root of r squared, and that gives me 9r. You try number 14. And did you get it right? If you reduce that a to the 10th over a to the 3rd right here, that's a to the 7th. Now we're going to simplify that into a to the 6th times a to the 1st. So that gives us, again, a to the 3rd square root of a, because when we take the square root of a to the 6th, we get a to the 3rd, but when we take the square root of a to the 1st, that has to stay under the radical. Lots of tricky pieces here. I'm going to host a Zoom session again, probably on Tuesday, or excuse me, Monday or Tuesday, to prepare for the test. And I am hosting one today as well. So again, now we don't have them apart, we're going to put them back together. Because if I put them back together, I can see that 98 divided by 2 right here, that just gives me 49 under the radical. And t to the 6th over t to the 4th, subtract those exponents and you get t squared. Now when we go ahead and take the square root of 49, we get 7, and the square root of t squared is t. And there's your final answer right there. So good luck, keep plugging away. I would even recommend you go back and watch the first several videos, just watch them again, because sometimes it does take several times of hearing it and doing the same problems over and over to actually get the correct answer. I just see I made a little mistake here. The square root of 9 is not 9, it is actually 3. Sorry about that. All right, have a great day.